Solid-state batteries are the buzzword in the battery landscape right now, hailed as the game-changing technology that could transform electric vehicles and portable gadgets. But do they live up to the hype? The answer isn't entirely straightforward. Yet, a recent breakthrough from TDK Corporation, a leading name in the electronics sector, might just change the narrative. They've unveiled a groundbreaking material for solid-state batteries that boasts an incredible 100 times higher energy density than current options. This innovation could be revolutionary. Picture electric cars that can cover significantly longer distances on a single charge, or smartphones that can go days without needing to be plugged in. It's an exciting vision, but there's more to unpack. So how did TDK pull this off, and what implications does it have for the EV industry? Let's dive in and explore. For electric car drivers, the worry of running out of battery before reaching their destination, known as range anxiety, is a major hurdle when considering a switch from gas-powered vehicles. Fortunately, TDK's latest advancement shines a hopeful light on the future of EVs. Reminiscent of the brand's iconic cassette tapes from years past, TDK has developed a new type of battery technology, a solid-state battery. Unlike traditional lithium-ion batteries that use a liquid electrolyte, solid-state batteries rely on a solid material for their internal workings. The solid-state design holds the key to the breakthrough. TDK's innovation boasts a massive leap in power compared to their previous attempts. Imagine a car battery that acts like a supersized gas tank, allowing you to travel much farther on a single charge. This new battery packs a whopping 100 times more energy than its predecessors. Placed inside a smartwatch, the new battery could keep a device running multiple times longer than current battery technologies. For example, the Apple Watch currently lasts up to 72 hours in low power mode before needing a recharge, meaning it could potentially last several weeks with an improved battery. Other potential applications beyond wearables could include environmental sensors, according to TDK. While the initial application of this technology targets smaller devices like headphones and smartwatches, the ultimate goal is to scale it up for electric cars. With this powerhouse battery, electric vehicles could potentially travel a staggering 1,500 kilometers or 930 miles on a single charge. That's more than 3 times the range of most EVs on the road today. This significant improvement would drastically reduce range anxiety and make electric cars a far more appealing option for long-distance drivers. But the benefits extend beyond just range. Solid-state batteries offer a safety advantage too, since they eliminate the risk of flammable liquids present in traditional lithium-ion batteries. Additionally, they may offer much faster charging times, reducing wait times at charging stations and making daily commutes more efficient. Nuido, the CEO of TDK, isn't shy about his enthusiasm for the company's breakthrough. He envisions their newly developed solid-state battery material playing a pivotal role in a large-scale shift toward a more sustainable and energy-efficient future. This technology has the potential to revolutionize the way we power our society. However, the path from breakthrough innovation to widespread adoption isn't always smooth. Unlike conventional lithium-ion batteries that use a liquid electrolyte, TDK's solid-state design relies on a solid ceramic compound made of oxides. This ceramic acts as a bridge for lithium ions to flow between the battery's two components, the lithium alloy anode and the cathode. While this solid approach offers significant advantages, it also presents technical hurdles. Maintaining a stable connection between the solid electrolyte and the electrodes is more challenging compared to liquid systems. Additionally, the entire battery needs to operate under pressure, adding complexity to the design and manufacturing process. And TDK isn't alone. Major car manufacturers, especially from Japan, have been vocal about the immense potential of this technology. Toyota, for instance, has been heavily investing in in-house battery development and aims to bring solid-state batteries to market by the end of 2027. However, this date has shifted multiple times, highlighting the unforeseen challenges in scaling up this tech from the lab to mass production. As the future of solid-state batteries unfolds, a new type of battery design called semi-solid-state has emerged as a stepping stone. Chinese automaker NIO exemplifies this approach, offering semi-solid-state batteries as an option on their ET7 sedan. These batteries boast an advertised range of 1,000 kilometers, a significant jump over current EV offerings. The development of solid-state battery technology is a race against time, filled with both promise and complexity. If breakthroughs like TDK's continue, the future of energy could arrive sooner than we think. Companies like TDK and car manufacturers like Toyota appear to be the front-runners in the race for solid-state battery dominance. While technical hurdles still remain, Breakthroughs like TDK's new material and the emergence of semi-solid-state batteries offer a promising glimpse into the future. We're standing on the cusp of a transportation revolution, with electric vehicles powered by safe, long-range solid-state batteries gradually becoming a reality. This shift could drastically reduce our dependence on fossil fuels and pave the way for a cleaner, more sustainable future for our planet. But when can we actually expect to see TDK's new battery in the market? Unfortunately, the road to widespread adoption may be longer than many had hoped. Motion, a consultancy specializing in the battery market, has tempered expectations, suggesting that mass market availability of this technology might not happen until around 2035. The primary reason: cost. Currently, a typical EV battery accounts for roughly 1/3 of the vehicle's total cost. However, with NIO's semi-solid-state battery, that figure shoots up to 50%, and a fully solid-state battery would likely cost even more. Iola Hughes, an analyst at Motion, explained that while solid-state batteries have long been a hot topic in the battery industry, there's a consistent theme: delays and missed targets. Lower third. Iola Hughes, analyst at Motion. She emphasized that while technical advancements like TDK's breakthrough are exciting, the true challenges lie in cost and scalability. Manufacturing these batteries needs to become cheaper and more efficient before they can realistically compete with today's lithium-ion options. On top of that, solid-state batteries also face technical concerns. Solid-state batteries are expected to require a complete overhaul of current manufacturing processes, which presents both an opportunity and a challenge. If mass production can be scaled efficiently, we could see dramatic cost reductions over time. However, the production process for these batteries is still in its infancy. The current cost to manufacture these new batteries is significantly higher than that of lithium-ion batteries. But as more breakthroughs occur in materials science and manufacturing techniques, costs could come down. In addition to cost, scalability remains a major hurdle. While the performance of these solid-state batteries is promising, it will take time for the industry to scale production to the levels required for mass-market vehicles. Some companies, like TDK, are focusing on small-scale applications like wearables, but scaling this technology to fit electric vehicles will be a monumental task. The manufacturing processes required to build these batteries are far more complex than current lithium-ion battery production methods. Each solid-state battery requires precise construction, and any defects in the battery's ceramic materials could affect its performance and safety. These challenges make it clear that widespread adoption won't happen overnight. Another key challenge is the long-term stability of these batteries. While solid-state batteries have significant advantages in terms of safety and energy density, there is still uncertainty about how they will perform over the long term. Early testing and research are promising, but much remains to be seen regarding how these batteries will handle long-term cycling, which is recharging and discharging over time, and extreme conditions such as hot or cold temperatures. Despite these challenges, there is no denying the excitement surrounding the development of solid-state batteries. Industry experts agree that the potential benefits far outweigh the hurdles that need to be overcome. Not only could they offer safer, longer-lasting energy storage, but they could also reduce the environmental impact of battery production. If successful, solid-state batteries could be a major leap forward in the quest for sustainable green energy solutions. As we look toward the future, the next few years will likely be critical in determining whether solid-state batteries can move from the lab to the marketplace. Companies like TDK and automakers like Toyota are making significant strides, and continued innovation in this space will likely shape the next generation of electric vehicles and portable electronics. However, before we see these batteries on the roads or in our devices, there's still a lot of work to be done. In conclusion, TDK's breakthrough with solid-state battery technology is an exciting development that could have far-reaching implications for the electric vehicle industry and consumer electronics. While challenges remain, both technical and economic, the potential of this technology is undeniable. If manufacturers can overcome these hurdles, we may one day see a revolution in the way we power our devices and our vehicles, ushering in a cleaner, more efficient energy future.